Can quantum mechanics create a new universe? What if all of this wasn't a one-time event? What if our sprawling, magnificent universe isn't the whole story, but just a single chapter in a library of cosmic proportions? For a long time, that was a question for philosophers and science fiction authors. But something's changed. Physicists are now looking at the fundamental rulebook of reality, the bizarre and wonderful laws of quantum mechanics, and asking a question that's almost too big to wrap your head around. What if the power to create a new universe isn't hidden in some giant cosmic explosion, but in the ghostly behavior of the smallest things we know? Scientists are exploring the staggering possibility that the weirdness of quantum mechanics could let us cook up a new reality from, well, nothing. Could we actually become architects of a new cosmos? To even start to figure that out, we have to take a journey to the absolute edge of what we know about physics, and maybe even a little beyond. Section 1. The standard story of everything. To figure out how you might build a universe, you first need a recipe. For the better part of a century, the story we've told is the Big Bang. It's a story that starts about 13.8 billion years ago with a point of impossible density and heat, a singularity. From that single point, everything we see, from the most distant galaxy to the phone in your hand, burst into existence. This epic expansion was guided by a set of cosmic laws, the fundamental forces, gravity pulling galaxies together, electromagnetism holding atoms in one piece, and the strong and weak nuclear forces running the show inside the atomic nucleus. For a while, we thought that was the complete picture. But there's a huge problem with this story. It has a hard beginning. And physics gets really squeamish about beginnings. A singularity isn't an explanation. It's a point where our theories throw their hands up and quit. That's why many physicists now see the Big Bang not as the ultimate origin, but as a bounce. Exciting new models propose that our universe might have emerged from a prior state. Some theories suggest it was born from the collapse of a black hole in a parent universe, with the Big Bang being the rebound. Others imagine a cyclic universe that expands, contracts, and bounces forever. These ideas try to avoid that troublesome singularity. To understand them, we have to leave the world of stars and galaxies and dive into the bewildering realm of the quantum. Section 2. The strange rules of the micro-world. Welcome to the quantum world, where common sense is not invited. Here, particles don't have one set location until you check on them. They exist in a cloud of possibilities, a state of being everywhere and nowhere at once called superposition. It's like a ripple on a pond, exploring every possible path at the same time. But the quantum world has an even stranger trick. It's a phenomenon so odd, Einstein called it spooky. It's the idea that what we call empty space isn't empty at all. It's a simmering, bubbling sea of energy called the quantum vacuum. And out of this vacuum, pairs of particles can spontaneously pop into existence, borrowing a little energy from the void before annihilating each other and disappearing. They're called quantum fluctuations. For years, these were just seen as a quirky feature of the subatomic world. But what if this constant dance of creation and destruction wasn't just a small-scale sideshow? What if it's the engine that could kickstart a whole universe? The secret ingredient is one of the most bizarre ideas in all of physics: quantum tunneling. Imagine a ball in a valley. Your everyday intuition and classical physics says that if the ball doesn't have enough energy to roll over the hills, it's stuck. But quantum mechanics says there's a tiny but real chance the ball can just disappear from one side of the hill and reappear on the other. It can tunnel through a barrier that should be impossible to cross. This happens with particles constantly. But what if the ball wasn't a particle? What if it was an entire microscopic baby universe? Section 3. A universe from nothing. This is where things get truly mind-bending. Physicists like Alexander Vilenkin and Andrei Linde took these quantum rules and asked, could a universe tunnel into existence? Their models suggest that from a state of nothing, a universe could spontaneously appear. But let's be clear, nothing in physics isn't what a philosopher means by nothing. It's more like a state with no space, time, or matter, often imagined as a quantum vacuum or a timeless, spaceless state. One of the most famous of these ideas is the no-boundary proposal from Stephen Hawking and James Hartley. It paints a picture where, if you could go back to the Big Bang, you wouldn't find a sharp starting point. Time itself would blend with space, and asking what came before would be like asking what's north of the North Pole. The universe wouldn't need a cause because it would be a self-contained loop. It would just be. In these quantum cosmology scenarios, our universe might have started as a tiny quantum fluctuation. This bubble of potential, through the miracle of quantum tunneling, could have popped into existence. Once here, it would be filled with an unstable energy, a false vacuum, that would trigger a period of frantic expansion known as cosmic inflation. This process would take a universe smaller than a proton and blow it up to astronomical size in a tiny fraction of a second. While inflation is a leading theory, it's worth noting that it's still actively debated, with some recent models suggesting gravity and quantum effects alone might explain our cosmic structure without it. But all these theories describe a spontaneous random birth. They tell us how a universe could happen. They don't tell us how we could build one. Section 4. The Laboratory Universe. So what if we didn't have to wait? What if we could give the cosmos a little nudge? This is the hypothesis of the lab-grown universe, and it is firmly in the realm of deep speculation. Physicists like Alan Guth and André Linde have sketched out how a super-advanced civilization might pull this off. The basic and wildly theoretical idea is this. You'd need to create a bubble of unstable, high-energy false vacuum. Then, by packing an unbelievable amount of energy into one spot, you could potentially trigger a quantum tunneling event. This wouldn't create a big bang in your lab. Instead, the bubble would warp space-time so fiercely it would create a tiny wormhole, pinching itself off from our universe to become its own separate cosmos. From our side, we might see a microscopic black hole that evaporates almost instantly. But if you could cross that threshold, you'd find yourself in a brand new, rapidly inflating baby universe. Let's be crystal clear. This is at the absolute farthest edge of theoretical physics, with no experimental support. The energy needed would be beyond staggering. It would require a complete mastery of quantum gravity, the still missing theory that unites Einstein's relativity with quantum mechanics. Without that unified theory, creating a universe is, for us, a thought experiment and nothing more. Section 5. The Architect's Paradox. But let's dream for a second. What if we could do it? What if we could stand at a console, push a button, and become cosmic creators? This leads to a pretty stunning paradox. According to these theories, once that new universe pinches off, it's gone. It's causally disconnected from us forever. We could never look inside, never visit, never even confirm it worked. Did we just create an empty, lifeless void? Or a vibrant cosmos teeming with stars, planets, and maybe, one day, beings who would look up at their own sky and wonder how it all began? The moral questions are staggering. What responsibility would we have for a universe we could make but never ever touch? In a wild twist, some physicists like Avi Loeb have even floated the idea that our own universe might be the product of a lab experiment by a more advanced civilization. We could be the inhabitants of someone else's successful project. This journey, from the Big Bang to the quantum void and back again, shows that the universe is far stranger and more amazing than we ever thought. The quest to understand these ideas pushes science and philosophy to their absolute limits. If this dive into the nature of reality sparked your curiosity, consider subscribing and joining us as we keep exploring the universe's biggest questions. So, can quantum mechanics create a new universe? From the frontiers of physics, the answer is a mind-boggling, qualified maybe. The spontaneous creation of a cosmos from a quantum state is a plausible, if unproven, idea. Deliberately creating one in a lab, however, remains a goal so distant it's almost mythical. We aren't architects of reality yet, but we're not just passive observers anymore either. We are the part of the universe that's starting to read its own blueprints. The fact that we can even ask the question, can we create a universe? Is a testament to the sheer power of human curiosity. We're standing on the shore of a vast cosmic ocean, and while we can't create new worlds today, just asking how might be the most important first step of all.